Yes, Japanese UPS is beeping. Please turn it off. Or check the power supply. Yeah, what happened? That UPS is beeping. So either turn it off completely or try to look for its power supply. Try to fix that.
Stand on the
Okay, one more thing. You didn't start the theory course, I suppose. I mean, not too much. Maybe 2 classes or 3. Okay. So basically, all these items that you're going to talk about over here are going to be totally new to you. You may not know what's happening, why happening. Okay. Many questions can be there. So the problem is we don't have that much time to cover up all those items here in in this software classes. We don't have so much software classes, only just two at most, 2. This is the first class. I'll try to finish everything within this class. If I cannot, I'm gonna take one more class on software, but not more than 2 classes. That means everything needs to be done within 1 or 2 classes. Okay, everything. You understand what I mean? That means most of the things, I don't have that much time, so I cannot go through all those questions, cannot answer all those questions. Why? Happening? What? Like that. Okay? So the idea is, do not just think about those questions. You're gonna get the circuit over here, and we'll look at what to do with it, the graphs, the calculations, whatever. Okay? So main idea is gonna be how to do those things using the software. Okay? So do not just go for those questions. They're gonna be answered slowly in your theory course. Okay? So that's the idea. Am I clear?
Yes, sir.
Well, so the first circuit is going to be this one, experiment number 1. Here you got a source. Okay? This is an AC source, and the waveform, well, more than one waveform is possible for this source. For example, usually we go for sinusoidal wave. Then you can also go for what you call square wave, triangle. Okay, like that. Everything is possible, but we're gonna just talk about the sinusoidal one over here. We're gonna use this guy over here, not the other 2. So, okay, 2 properties of this waveform. Number 1, the amplitude, and number 2, the frequency. 2 things are over there. Amplitude for this guy is gonna be 5 volts, and the frequency of this source is gonna be 1 kilohertz. That's it. Okay, 2 properties of this source. Next item, we have a capacitor over here of 1 microfarad. Okay, and a resistor over there with 220 ohms. Now, this is this is series circuit, only one path. So one current is gonna come out of the source. Okay, travel the whole way, all the way, and then also get into that source. We also need that. And number 3, this guy we also need. the voltage across the resistor, okay, VR plus here minus there, okay. This is the source Vs plus minus. So that's it. This is the circuit. Now, question is what to do with the circuit. What to do? Okay, these are the items that we need to find out. Number one, this source, okay, there is something called the RMS value. Something is known as RMS value. You don't need to know what that is, okay? Slowly you're gonna learn that. The idea is we need to find out the RMS value of this waveform, sinusoidal waveform, okay? Then, source is sinusoidal, voltage is sinusoidal, the current, that guy is also going to be sinusoidal, okay? So this has got another, the same thing, the RMS value. You need to find out the RMS value of the current as well. Then there is one more thing known as the impedance, okay? Denoted by Z, capital letter Z, and it has got two things, one magnitude, one angle, okay? We also need to find them out. That's the objective. That's the impedance. And to give you a little bit of idea, this guy, the property of this guy, this is known as a resistor. Its property is known as resistance. It resists the flow of current. Okay? You know the characteristic of that guy. So this guy is also like that. Is also like that. Okay? But not exactly this. Because basic elements, okay? Three basic elements are over here. The R guy, the C guy, and the L guy, RCL, these three people. Resistor, capacitor, inductor, okay? These items. So when, it, the property, it resists, that guy also does the same, L also same, okay? When you combine their resistance, there is a little bit of problem with, that term resistance, it refers to this guy, but don't think about that. Suppose resistance means, use the actual meaning. It resists the flow. All three people resists the flow. So their combined resistance is represented by this impedance. That impedance is the combined character of resisting the flow, like that. Okay? Is it clear? So that's Z. We need to find this. Well, one more thing. Okay, so electrical circuits one, DC circuits, they're only one thing. Voltage, one value. Current, one value. Resistance, one value. Everything, single value. Just a value, just a number, nothing else. But here, the, the AC circuits, it's a little problem. Just one single number and gonna do the job. Okay? You need to take help. All those quantities are gonna be complex numbers. Number one, complex numbers. Okay? And complex numbers have got two representations. Okay? Two representations. One is like this. Okay, let me just write it down over here. Complex numbers. Yeah, these are their representations. X plus jy, one form, r angle theta, another form. Okay? It's known as real quantity, that is imaginary quantity, these names. This is magnitude, that is angle, okay? This is how we call them. So, all quantities, voltage, current, that impedance guy, all people are gonna be complex in nature. So either you go with this or that. Form. for representing them. Okay, we're gonna choose this guy. Usually we choose this guy, this form, magnitude angle form, to represent all those people. So that's why, magnitude angle, they're everything. Okay.
What is RMS?
Yeah, don't ask that question, what is RMS? That's gonna be answered in your theory course, okay? So just keep in mind, we need to find something called RMS, and you need to know how to use this software to find that RMS. That's the question here, okay? We don't have that much time to explain all those items to you. So, let's see how to do that. Well, okay, let's get started. So what I'm going to do is that I'm going to just create this guy over there, okay, using the software. I'm going to just construct the circuit and then do the simulation, find out some graphs, and slowly we're going to find all of them out, one by one, okay? So let's start. So you need to start there with that icon called Get New Card. You need to do a little bit of shopping, okay? So how many elements do we need over here? 3? Yeah, basically 3. So let's start with the source. The name of the source is this, BSIN, okay? BSIN. So I'm going to bring one copy of that. Done. Next, we have a C over there, so let's bring it as well. C, done. Next guy in line is going to be the R, also done. So 3 elements we need and 3 elements we got, okay? But then again, one more item you need to just play with the circuit. What is that? That is known as the ground. You know, you already heard about it, I suppose. This software works based on the principle known as nodal analysis, and that analysis cannot be performed without the help of a ground. That's why you need to bring that guy also there. One more item, the ground. And there are more than one grounds available in this software. You can use any one of them. I'm going to use this guy. Well, where is it? So GND, I typed there, something just popped up over here, known as GND underscore analog. Looks like a big arrow, okay? I'm going to bring one copy of that. This is our ground. Now, done with all those elements. So let's arrange them, let's build up the circuit. I'm going to make this guy vertical and keep somewhere here. You can put the ground at any place, at any node you like, but usually we choose the negative terminal of the source. That's why I'm going to just connect it with this negative terminal. Okay, this is the negative terminal of the source. So there. Now we need to just join them together. Joining, almost done. Yeah, that's it. Done with the circuit. Now what to do? Configure the circuit. We need to do a little bit of changing the values, names, or whatever. So at first, this is the, what do you call, source, yeah? The name goes like V1, and here I have used VS. So I'm going to change that. How to change that? You just double click on V1. That window is going to appear, okay? And there you need to just type VS. I typed VS, clicked on OK, so there you go, the name got changed. Then the name is on the right hand side. I like to put it on the left. How can I do that? Multiple ways of doing so. I'm going to choose the easiest way. I'm going to flip that guy. That means flip the source. If I flip it, it's going to do, flipping means something like this. Okay, that's known as flipping. How do you do that? You just select the guy at first and then press Ctrl F to flip. Just like rotate, Ctrl R, like that. But before you do that, you need to select it. How do you select that? You just click on the symbol. So it turned red, then it got selected. So Ctrl F is gonna flip that. So done with flipping. Now the name is on the left hand side. Done. So this is done with VS. Now you need to do something about them. Okay? These have to do with the frequency, you need to fix them. How do we do that? You just have to double click on the symbol. Yeah. So double click on it. You can see many options over there. We're going to start with something called VOFF. Okay? This is definitely not the amplitude, not the frequency, but then again, without this guy you cannot work with the circuit, without that guy you cannot work with this guy. Okay? So that's it. You don't need to know the definition. Just keep in mind whenever you use that VSIN guy, you set this property to 0 always. Okay? So VOFF basically a voltage. It should have the value 0 volt and that's it, done. You don't need to understand anything else about that. So I'm gonna set it to 0 volt. And then either save attribute, click on that button or press enter. Anything is just fine. Done. Now, next guy in line, VAMPL. This is what we need. This is known as the amplitude. Okay? The amplitude goes like 5 volts. So we need to set it to 5 volts. 5V. Enter. Done. Then the last one is the FREQ property. This is known as frequency. And you need to set it to 1 kilohertz, 1 kHz. So value box 1 kHz. And then press enter. So finally, you configured the properties of the source. Okay? Okay, now one more thing. I have displayed the property on the circuit over here, amplitude frequency, but there you got the name only, VS. No amplitude, no frequency on the circuit. Okay? You can bring them in if you like. So I'm going to do that. You need to learn how to bring them in. AMPL here, FREQ there, so why not make them visible here as well? That's the question. The question is, how do you do that? Again, first things first. You just select the property you want to get on the circuit. So VAMPL, I selected it, done. Once you're done with the selection, then you need to change the display property. Okay? Display property is over here. You see, change display. I clicked on that, so another window appeared, small window, and there we're not interested in the whole items, okay? Just interested in here, what to display, which says what to display. Value only, name only, blah blah blah, whatever. Our option is going to be this guy, both name and value. That means once you select that, the name VAMPL and the value 5 volts or whatever get displayed on the circuit. Okay, that's just like a picture. Okay, so just like a stamp. So you just select this guy, click on OK, click on OK again. No, not this OK, only this OK, because we're not done with all of them. We need to make the frequency also visible. So same way, AMPL, change display, name and value, okay. Done with AMPL, do the same thing for FREQ as well, okay. So both name and value, okay. Then go for the frequency, change display, both name and value, okay. Now finally we're done. So clicking OK is going to solve the problem. But another problem just appeared. Something appeared over here, that means those two people, but one on top of the other, overlapping, okay. So you need to separate them, okay? How do you do that? You just take your mouse pointer here and click on that. Only one item is going to be selected, not both, one item. Which one is going to be selected? The one that you made available at first. That means VAMPL is going to be selected at first. So click on that, just a single click and then move it. Like this. Clicked on it once, got selected. Now I'm just going to move that to somewhere here. Okay? And I'm going to do the same thing for this guy as well. So let's place them properly. One item here and the other item to another place. There. Is it okay?
Yes, sir.
Well, that's how you do it. Done with the source. Now let's go to the capacitor. C1 is the name, let's change it to C. And 1 nanofarad is the capacitance, let's change it to 1 microfarad. 1 U and F. 1 microfarad. Next guy in line is R. So I change the name to R. And 1K is not going to work here. 220 ohms. 220. the omega symbol is not available. So forget that. And by the way, it has also overlapped. So I'm gonna just remove that as well.
2, 3.
Now finally done. Okay? This circuit almost looks like this. Only two items are missing. This I, that VR. These two labels, names are missing. You can bring them in as well. Okay? You just need to know how to bring in labels. Okay? So let's see. Do you see this button over here? It says, once you put this guy there, it's gonna say draw text box. I'm gonna just use that now. So let me just click on it, done. You see, you got a pencil over there. Now click here once. So a box is gonna be like this. It's gonna appear. And then once you're done with the size, click once again. Done. You don't have the fixed box. So cursor appeared there. Now you need to type whatever you need. For example, the first one, it says I and an arrow. Okay? So let me just type I, done. And I need to type the arrow as well because there is no picture like an arrow. So I need to type that. So how do you do that? Like this. 2 minus symbols and 1 greater than symbol. Looks like an arrow facing rightwards. Okay? And I'm gonna just use some spaces over there as well in between I and arrow. So let me just use 2 spaces. So that's it, done. This is the I. Yeah? You click here, get a pencil, then click anywhere here once. A movable box is gonna appear. Then you select, go for a suitable size, okay? By moving your mouse. Then click once more to lay a solid box, okay? Once you get the solid box, inside you're gonna get the cursor, and then you start typing. Okay? That is how you do that. Bring in the label, any label you like. Okay, I'm going to resize the box because it's too big. So, yeah, that's a better size. Now I'm going to put it somewhere here. Looks nice, but I need to remove the border. Okay, how do I remove the border? You double click on the border. Done. What was the color of the border? Green. So you see green over here. And then the border is known as frame. Okay? So how to remove that border? Just change the color of the frame. Make it none. Okay? Just a minute, just a minute. So I clicked on color, then scrolled up, got the none option, clicked on it, then clicked on OK. So the border is still there, but no color is available to show the border. So when I click outside, the border disappears. Okay? Yeah. No, not that box. I'm talking about this box. This is some other box. Okay? Well, then the next item is VR with a plus on top and a minus at the bottom. Okay? You also need to bring that box and type everything. So let me just do that as well. Again, click on the box. Click once. Movable box appear. Fix a size. Then go for another click. Solid box is there with a cursor. Now type everything. Plus V R like that. Whatever I showed over there, and then a minus. But they're too much congested, so I'm gonna use spaces, blank lines. Like this. Then is it okay? I don't know whether it's gonna be okay or not. Okay. Let's use one more space, one more blank line on top and at the bottom. One more. I think now it's fine. So I'm going to resize the box like this and then remove the border. Okay then, finally done with everything. So the circuit I showed here is there. Done with the circuit. Now, please understand, placing these labels is nothing to the computer. Okay? I mean to the software. The software doesn't know anything about them. They're just pictures. they do not have any meaning to the software. Okay? So please keep it in mind. They're just labels, some pictures, nothing else. Now we need to tell the software guy what we need to do with the circuit. We need to tell him. Okay? So what's the idea? You need to find out some graphs. That's the idea. That's the point. That's the target. Okay? What's the characteristic of the graph? X, Y, what's the characteristic? What you're gonna have on X and also on Y. Okay? So we're gonna have time on X, okay? Time on X, and Y is gonna have anything. For example, voltage, current, whatever on Y. Okay? So that's our target. Now you need to tell the software that you need that. How do you tell that? You already know it. You have to click here, set up analysis, then go for transient. Why transient? Because X is gonna have time. That's why transient. This one. And how to configure it? Well, forget this part, not needed. You are interested here only. And then again, by the way, print step is not necessary. Forget that. Final time, yeah, necessary. Final time means, suppose this is a graph and okay, let me just draw something. Starting time here, 0, and final time is that one, the last time. Okay? Now, the question is, what should be the final time? How to answer that? Well, this is a periodic waveform. One period corresponds to a certain amount of time. For example, this guy, 1 kilohertz. This is the frequency. What's the period of that guy? 1 millisecond. Yeah, that's it. That means one cycle needs 1 millisecond. So that means how many cycles you need? The final time depends upon that. Okay? So let's now choose how many cycles we need over here. Sinusoidal. Okay. Let's say 100 cycles. The first 100 cycles. Okay? The idea is to have many information available and then doing something. Okay? We're gonna see it later, what to do on that big amount of information. But at first, simulate a big amount of information, okay? Which you can work on. So first 100 is just a rule of thumb, first 100 cycles. One cycle, 1 milli. 100 cycles, 100 milli. So final time is gonna be 100 ms, okay? This is your 100 milliseconds, done. No print delay, not needed, because we're going to start right here with 0. If you do not want to start at 0, but at some other point of time, you just mention it over here. Okay? So no need to use it now. Forget that. Step ceiling, yeah, important. Step ceiling. What is step ceiling? Again, get back to your initial idea about schematics, electrical circuits one laboratory there. You learn about it. In order to come up with a smooth, nice, exact curve, you need to have many points, data points. Okay? Many points mean, okay, what's the characteristic of one point? One coordinate, another coordinate, x, y. Okay? So many points mean many x and many y. Forget y. Y depends upon x. X is independent, y is dependent. You know that, variable. Okay? So you fix x, accordingly, the software is going to fix y. You don't have to think about y, just think about x. Okay? So many x means what's the gap between two x's? Very small. Very small. It has to be. That small guy needs to be here. That is the meaning of step ceiling. In short, not exactly, I'm not talking about the exact meaning of step ceiling, but just an easiest way to think about step ceiling. Okay? So how to fix that? Well, depends upon because you're dealing with a periodic waveform, depends on the period. With respect to period, it has to be small. I mean that guy. Okay? Because small is a relative term. 1 second is small, yeah, you don't feel it maybe. 1 millisecond also small, 1 micro also, 1 nano also, but which one to go for? Okay? Depends upon the period. That small quantity needs to be small with respect to the period. The period is how much? 1 milli. So 1 second to you, to me, small, but not small to him, to 1 milli. So you have to go for, think about that. So how to fix it? Rule of thumb goes like period by 50. It's quite small compared to the period. Our period is 1 millisecond, so 1 by 50 is going to be 0.02. This guy. This millisecond is a very small quantity, so let's have it there with step sailing. And remember, what did I do? Period by 50. Okay? So this is 0.02 milliseconds done. Now there are 2 points, details, bias point, this one, and skip initial transit. Okay, that point.
Sir, print step will it be millisecond?
Yeah?
Print step will be millisecond?
Forget print step. We don't need to fix it. Okay? Just forget that. We only need to work on this and that. The final time and step sailing here for our purpose. Okay. Now the point is this one and that one I was talking about. So forget this guy, we don't need them. I just need to use this one. This one. Why? I'm gonna tell you later. You may know it already, but then again, I'm gonna tell it later. So please check this option on. Skip initial. Okay, then close. Now let's talk about that initial checking. Why did I do that? Because this guy has got something called the initial condition. Electrical circuits one, there you learned it. Capacitors, inductors have got initial condition. For capacitors you have voltage, initial voltage. For inductors you got current, initial current. Through them, across it, like that. Okay? So we're gonna just consider that there is no initial condition for this guy, the C guy. That means no voltage across it. That means the initial voltage for C is gonna be 0 volt. And you need to fix that. Okay? How do you fix it? You double click on that at first. Then select this property known as IC. IC means initial condition. Okay? It should be set to 0 volts because the initial condition for a capacitor is a voltage. Okay? Zero B and then enter. And you need to display that on the circuit. So change display, both name and value. Okay, okay. So IC appeared. That's overlapping with the name C, so I'm gonna bring it down. 0. Is it clear? IC 0 volt. Now the checking skip initial, that guy, why did I check it on? Because if you want to fix an initial condition for a capacitor or for an inductor, fixing the property called IC is not just enough. You need to go to transient, you need to check the skip initial, that guy, to just make it available. If you just fix it only, do not check that option on, that software guy isn't going to take care of it at all. Okay? So you need to type the value, you need to check the skip initial, then the software is going to take into account this guy, okay, this initial condition, the voltage or current or whatever. Okay then, now finally I convert the message. I need a graph, X, Y, whatever, done with that, with setup analysis. Now finally, which items do I need on the Y-axis? Y, done with X, now Y. Okay, right, at first we need to talk about this guy, the voltage. We need this guy on Y-axis. Okay, how do you tell that? You just use markers to convey this message that you need the graph on Y. Okay, markers. Where can you get the marker? Well, marker is available here, there, marker. Okay, 2 markers are available. Voltage, current. What do you need here? Voltage. Okay, then you go with these two. These two are voltage, voltage, voltage. Okay, but there's a difference in between those two. The first one, marked voltage level, works on nodal voltages. The second one, marked voltage differential, works on any voltage, no matter nodal or not. Okay? And nodal voltage means which one? Okay. Well, where is our ground? Here. There you have your ground. So if I say something like this, okay, nodal voltage of this node, there's a meaning. You did nodal analysis. There's a meaning. What's the meaning? What do we mean by nodal voltage of this node? We mean the voltage of this node with respect to ground. That's it. That's the meaning. Okay? But what about this guy? What about this guy? Let's say here. It's also a voltage. Is it a nodal voltage? No. Because nodal voltage needs the ground. For example, this guy needs the help of a ground. With respect to ground. With respect to what? Is it ground? Is that ground? No ground. So this is just a voltage, not a nodal voltage. Some voltage, but not a nodal voltage. Nodal voltage needs a ground. For example, if I say nodal voltage of this node, what do I mean? Okay, voltage of this node with respect to ground is the nodal voltage of that node. Okay? So you need to understand. Now, which one is our target? This guy. We can select it. I mean, look at this, plus minus. So if I say this is the voltage of this node with respect to ground, am I correct? Definitely I'm correct. Because voltage of this node gets the plus, with respect to gets the minus. Okay? So according to the definition, this nodal voltage is the same as Vs, which we need. Okay? So I'm going to use the first marker, nodal marker, to mark this guy over there. Okay? How do you do that? Click on that. You see something moving? You just place it on the node where you need the nodal voltage. That means here. Done. This marker marks this node. That means it's gonna take the nodal voltage of this node. That means voltage of this node with respect to that. Plus here, minus there. So done. But here they are a little bit overlapping over here, so I'm gonna remove it. I'm gonna put it on the right hand side. Done. So right now I have only one voltage. Okay, no problem. Then next item in line. Which one to get? After we're done with DS. This guy. We need this as well. I, the I guy. Okay? I, the current, which is going this way. How to get that? Again, marker. Which marker? Well, let's go there at first. There is only one marker to get a current. Number 3 from top. Mark current into pin. Only one marker for current, but 2 for voltages. Okay? So mark current into pin. You just well, there is a rule of placing this guy. You can place it anywhere you like, on any node you like, the voltage marker. But current, well, no. You cannot place it on any node you like. You have to place it on a terminal of an element. Remember, okay? So, this is an element, choose whatever you like, okay? How many terminals? 2. How many? 2. How many? 2. Place it on any terminal. That's the idea. You have to place it either here, there, or here, whatever, okay? But then again, putting it has got a connection with the direction of the current. For example, if you put it here, then the direction is going to be this way. If you put it there, the direction is going to be this way. Why? Because that marker finds out the current which is getting in through the terminal where it is placed. Okay? That's the definition. So that's why we're going to put it somewhere here. There. The direction is this way. Okay? Now the last option, VR, also nodal, minus ground. So nodal of this node. Voltage marker, nodal voltage, and that's it, done. Are we clear? So I have attached 3 markers that's gonna display the quantities on the X, Y axis, not X, Y. Okay? So finally, we can save it, create a new folder on the desktop, and save all the files there. Done with saving. And now, open the design manager, piecewise design manager, this guy. Select this icon from top, the second icon which says run piecewise, click on it. A new window is going to appear soon. Well, it has appeared. This is the new window, piecewise AD, the name of that. So, what you need to do? Nothing. Just minimize that. Done. Then get back to your circuit. Here. Now you need to click on this guy. It says simulate. This icon. Just click on that.
Sir.
Okay, just wait a moment. Now the piecewise AD, this window, which I just opened, okay, has got many information. You need to start with this box, this small box, which says something. The last line is the most important one here. For me, it says simulation complete. That means I don't have any errors with my circuit. For you, it may be different. If you see simulation complete, you're just fine. But if you do not see simulation complete, that means you have problems, you got errors, and error messages are going to be also there. So you need to check those messages and you need to solve the errors before you can do the simulation. Excuse me, no talking. Yeah, what was the question? I showed you a better method of doing so you should follow that. Okay, not a problem. Then ask someone else what I showed over here. Okay? No. Now okay, so I was here, simulation complete. Suppose everyone has got simulation complete. Suppose. Then you need to look at this place. This place is gonna get the graph, the black screen. Okay? So X here, Y there. X says time. Okay? There is time written over here. This is the first value, the usual value 0, and that is the last value which says 100 milliseconds. Okay? Now the Y guy has got 3 quantities. 3. This guy, this voltage, this current, this voltage. 2 voltages and 1 current on Y. 3 people. This is some voltage. The notation goes like V first bracket, so voltage. This is current I first bracket. There is another voltage V first bracket. Okay? So, and also, yeah, some graph is there, may not be quite visible or maybe too much information. Well, we're going to fix it later. At first, the idea was to get these names because to you, this is VS, to us, I, to us, VR, but the corresponding names within the software is not so much simple. Okay? For example, VS is not VS to him. To him, it's V first bracket VS colon plus, something like this. I to you is just I, but here it says I first bracket C. Then VR to you is just VR, but here it says VR colon 2. So the names are a little bit difficult. Okay? So if you do not attach those markers, you will just, spend a lot of time in finding out those names. Okay? For your quantity. That's why we attached markers. So we got the names and now you can play with it. Just keep a note of the name. Okay? Maybe you can just write it in your class note there. Okay, these are my quantities, I need to work with them. That's it. That's the idea. So finding out names is the most important thing. And now we're gonna just remove them from y-axis. Hey, what are you doing? Sakibul Hassan, can you please concentrate here? All the people, I told you already earlier at the beginning, if you cannot keep up with me, you better switch to your class note. But don't start talking, because talking is not gonna get you anywhere. Okay? Anywhere. You better stop talking, you better put your concentration over here and just go through the ways, go through the things that I'm showing over here. You have got more than one quantity on the Y. You can work with them, no problem, but here, for simplicity, I'm gonna remove it. I'm gonna keep only one item on y-axis. That means this item only, y-axis is gonna be this item also on y, this item also on y. I'm gonna separate them, make them separate, okay? So I'm gonna find out 3, you can see one graph here only. I'm gonna just create 3 different graphs, individual, different, okay? On the first graph, we're gonna have this guy on Y, second graph, that guy on Y, and third graph, this guy on Y. You get what I mean? Did you get what I mean?
Yes.
I'm gonna make them separate, okay? So how do I do that? I need to at first generate graphs. First graph is this guy. I need to generate two more. How do I do that? This is how. You see the window? To you, this is graph, but to the software, these are just windows. So you just create two more windows. So I'm gonna click on window, then click on new window. You see, a new window, a new graph, a new black screen just appeared. Okay? And what's the name? This is A window, this is B window, AB. I'm gonna create one more. Okay? Done. So ABC, 3 people are there, 3 graphs. Now, just go to the first one. This guy, the last guy, is this one. Okay? So I'm gonna keep it there. The first one on the first window. So the second window is gonna get this guy, the I guy. So I'm gonna take this guy off from here, this graph, and I'm gonna put it there. Okay? I'm gonna take it off from A window and put it in B window. Am I clear? So you need to know how do you do that. You have to go to, move your mouse pointer on top of IC, that name, double click on IC, so something is going to appear, and you see IC already got selected over here, IC got selected over here, highlighted, okay? You just copy that name, okay? Control C, copy. Control C, done with copying. And now you need to remove it from Y. How? At first cancel. Then it's already selected. It's red. Red means selected. You just press the delete button to just remove it. Done. Gone. And now you copied it, so you're gonna paste it here. B window. So go to B window. And how to paste that? Nothing on Y. How to bring in something? Okay. You need to click on this icon which says add trace. That means adding something on the y-axis. Again, the same window just appeared. Cursor here, trace expression empty. You just press Ctrl V there to put that IC name. You see? IC appeared. And now you click on OK. So finally, IC got placed on Y. You can see IC. Done. So I'm going to do the same thing for this guy as well. No, not this guy. I mean this one as well. VR. VR is there. Take it out from A window and put it in C window. This one is the corresponding name for VR. Double click on that. Copy it. Cancel. Delete. C. Add trace. Paste. Okay. So done. Now let's check. First window has got VBS, which is BS, this guy. Second window has got I, which was I, no problem, that I. And the third window has got something called VR2. VR2 is nothing but this one, VR. Is it clear? So, I have separated all those graphs.
চাপ দিয়ে So, ওটা আরো লেংথি হয়, ওটা আরো বেশি সময়ের জন্য যায়। 20 সেকেন্ড ধরে রাখ, as much as you can. कैसा है? এখন কি কাজে দিছে? সাড়ে 12টা থেকে ক্লাস করতেছি না, 8টায় ক্লাস করছি।
আমার ভিডিও করে
Okay. Now again, let's talk about the BS graph. Okay. If you look at it carefully, you'll be able to find out cycles. This is one cycle like that. If you look at all those different cycles, too many cycles are there, 100 cycles are there. If you look at all of them, you're gonna see they have the same face, same shape, same property. All cycles are just the same, no change. Okay? If all of them are just the same, then you can work on any cycle you like, or any cycles you like. Maybe you can work on this portion, that portion, any portion you like. Am I clear? So I have got plenty of information. All of them are just like the same. So I'm gonna just now choose a smaller portion. Maybe 5 cycles I'm gonna choose. Okay? Then it's gonna, refine the view of that. You'll be able to see bigger cycles. So you need to just focus on a smaller portion from this huge information. So I'm gonna choose the last 5 cycles to zoom in. Okay, I'm gonna choose the last 5 cycles to work on. So how do you choose that? When you have all that information available, how do you choose that? You go to at first plot, because working on graph, that's why you need to go to plot. Then choosing a particular portion means again work on the x-axis. So you need to go to axis settings. Okay, axis settings. 4 tabs are there. 4 tabs. 1, 2, 3, 4. You need to work on the x-axis. So first tab is the important one here. We're already there. No problem. And now we need to work on the values. 5 cycles means what? 5 milliseconds. 1 cycle 1 milli, 5 cycle 5 milli, like that. Last 5 cycles means what's the time? The last time is 100 milli, but the first one should be 5 cycles before 100 milli. That means 5 milli before 100 milli. That means 95 milli.
95 minutes.
Okay? So basically we're talking about the data range. Data range, time range. It's here. It's here. 2 options. Auto, user defined. Automatic means full. Whatever we talked about at first. User defined means now what I'm talking about. 95 to 100. So you need to select this option. User defined. First one is the starting position. Last one is the ending. Last one is 100 milli, which is already fixed. You just type 95 milli in the first box. And then click on OK. You see something?
Yes, sir.
It has refined. Only 5 cycles are over here.
Yes, sir.
But the characteristic of the curve is a little bit problematic. We need to change that. How do you change that? Move your mouse pointer on top of the curve, then right click on it, select properties. I'm gonna select a suitable color, for example, this one, green, and I'm gonna change the width. Is it visible now? So I change the color and also change the width. Okay? 2 things. Finally, we got 5 cycles. Yes? What?
Hey,
Thickness. Well, you need to right click on the curve at first. Right click there. Yeah, now you know property.
using it.
There you change the color.
এরকম কেন না এটা
সার্কিটে বকরা চোখে
স্যার
Yes. It's okay. What's the problem with it? But I think you didn't go for what do you call step ceiling. Can you please go here? Click there. Not there. Here. Yeah, there. Setup analysis. There. Transient. Why is it 02? Where is the milli guy? 0.02 ms milliseconds. Milli is not there. We are working in seconds.
ওকে স্যার
Hey, excuse me. We just refined the view of that, what do you call, graph, and now it's our turn to find out the RMS. This is the instantaneous value. Instantaneous value of the voltage. You now need to find the RMS value of that. Please keep it in mind. Okay? AC waveform, two things. Instantaneous value, RMS value. This is instantaneous. Okay? Now we need to find RMS. How? Let's see how. Go to add trace, that button. Trace expression is empty. Cursor is blinking there. On the right hand side, you can see many options. The right box, the box on the right. Okay, many options. Those are mathematical operators that can do something on a graph, on a curve. Okay, so I'm gonna find something like, I'm gonna scroll down a little bit. You see something called RMS over there? You have to click on it once, not twice. Once. So that's gonna put a copy of RMS here. I clicked on it once, don't click on it twice, and more than once. So one copy got placed over here. And RMS first bracket something and the cursor is inside. You need to specify the graph on which you want to perform that RMS function. That means we need to perform our RMS on this guy. That means this instantaneous value. That guy means this one. The name goes like this. Okay? Where can I need to put the name over here. How can I do that? You need to find the name from this list and then click on it once to put it there. Okay? This has got voltages, currents, power, all three items. Turn off current, turn off power, just voltages are going to be there. So turn off. Okay? Now find out. VBS plus is this one, this guy. VBS plus. So move your mouse over there and click on it once. Click on it once. There you go. You see? RMS first bracket VBS plus inside. Okay? Now you have to click on OK. Something appeared not visible. Okay, I'm going to increase the thickness. Do you see now? A straight line. That's the RMS. Okay? Now, you need to keep it in mind that the RMS function has worked on the full data, 0 to 100. You are just viewing 95 to 100, but not the items before. Okay? So that's the idea. Now this guy is gonna give you the RMS, which is a single value. You need to just extract that value, get the value. Okay?
বাস
Did you get my point? I got the line, but I didn't get the value. I need to get the value. 1 volt, 5 volt, 10 volt, I need to get the value. How do I get that? This is the question. Okay. If you want to get the value of something, then you need to select a point on the curve at first. For example, this is the red curve. Suppose, this is just a straight line. All the values on that are just the same. Okay? So you can check the value from here, there, here, anywhere you like. Just select a point. For example, this point. Done. Done with the selection. Once you select a point, then you can tell the software, okay, give me the coordinates of that point. What do you mean by coordinate? X and Y. What do you have on Y? This guy. This is also on Y. RMS, first bracket something, also on Y. So you need to get the Y coordinate in order to get the RMS value from there. So that's the way. So I'm repeating. This is the curve. All points are just the same. carrying the same value. Select a point, suppose this one. Then tell the software what are the coordinates, x, y. You're not interested in x because you need the y. Why? Because y has got the information, the RMS. Then you just use the y coordinate to get your value. Done. Simple. Now the question is, how do you select a point? How do you tell it to show coordinates? How? Okay? That's our objective now. So, selecting a point. Do you see this button called toggle cursor? You have to click on that. Okay? This is gonna bring in two cursors. You use cursor to select a point. That's the idea. So you got two cursors, you can use any one of them. Okay? Now, how to use a cursor? Question is that. By using the mouse. Okay? By using the buttons. The left button handles one cursor while the right button handles the other. So I'm going to call one cursor to be the left cursor and the other one the right cursor. Okay? Left, right, like that. Okay? So I'm going to click here and then you got two items on Y. Okay? This is the symbol. Okay? On the first symbol, this is the first symbol. On the first symbol, around the first symbol, something is going to appear once I click that. Okay? So keep an eye here, there. Clicked on it, some box appeared. That box symbolizes cursor. Okay? So both cursors are symbolized by boxes. Both boxes are here. Both cursors are there. They're gonna work on the green curve, not the red curve. Okay? I need to work with the red curve. Okay? That means I need to bring the cursors on the red curve. How do I do that? Okay, now. Two are there, left, right. Anyone is just fine. I'm going to choose left. So I'm going to bring in the left cursor on the red curve. Now how to do that? Move your mouse pointer there on the red symbol. On the red symbol. Then you need to move the left cursor. That means left click once here on the symbol to just move the cursor. Done. So the left cursor is now on the red curve. The red symbol has got the box around it. Okay? So left cursor is on the red curve. Now you can move your cursor to select a point. How do you move that? Left click and hold and then move the mouse. Okay? So I'm left clicking and holding and moving the mouse. Do you see something? Moving over there. Do you see something? So let's put it on a particular point. Let's say here. Just any point you like because all the points have got the same value. Okay? So choosing a point is done. I have chosen a point. Now I need to display the coordinates. How can I do that? Well, do you see a button over here, mark label? You just left click on it. So, do you see something over here? Something just appeared, although not visible, but something just appeared. The structure is first bracket, x value, comma, y value. That is there. Okay? So we finally got the value. We just need to look at the y value. The y value says 3.5364. That is the RMS. Okay? So finally we got our answer. Now what to do next? Just turn off the cursor. So I turned it off, turn off both cursors. Let me just show you the print preview. No, I can't. Too many things to talk about. Do you see it now? This was the red line. This is the marking. This is the point, and these are the coordinates x, comma, y first bracket. So y is the important one. This one. This is the RMS. 3.5364, something like that. Okay. So this gives us this answer. Well, where did I leave the marker? Do you have it? Okay, something. You got its value. Done. The next one is gonna be this one. This one. And this one you can work in the same process. So I'm not gonna show it to you. Let me just tell you again, give you a brief idea. Let me just close that. You go to that window, too many items. Just zoom in on the last portion, 95 milli to 100 milli. So 5 cycles you're gonna get, and then apply the RMS on the whole to get a line and then find the point and find the coordinates to get this guy. This is a homework. You're gonna do it on your own. Okay? Now our point is gonna be this guy. How to get the magnitude and angle. Okay? Now let's see. This answer. Okay, we'll get this answer. Excuse me, where are you? Please be silent. We're gonna get this answer from the third graph. So I'm gonna refine it at first, and then I'm gonna do something on that. Let me just refine that. Okay, now I'm gonna increase the thickness. Yes. Target is this one. Okay, now a little bit about theory. This is the source voltage and this is the current. Okay, using these two people you'll get the idea of the magnitude of Z. Did you get me? And there's a formula which goes like this. This is the formula. Just like I equal V by R, Ohm's law for DC circuits. Okay? But this is going to be I equal V by Z. This is Ohm's law, the same Ohm's law, but for AC circuits. You're basically interested here or in Z. That means if I equal V by Z, Z equal V by I. Okay? So this is going to give you an idea of the magnitude. Now, how to get the magnitude of Z? Get the V value, get the I value, do the division, get it. Done. What is the V value? The RMS of this. What is the I value? The RMS of that. So you can do it on your own. Once you get those values, you can do it on your own, the magnitude. Am I clear? So that's the homework. Now, next target is this one, the angle. How to get, well, there are multiple ways of getting this information. I'm just showing you one way, not all. I'm just showing you one way. Okay, there are also multiple ways. When you do the theory, in theory course, you'll get the idea how to do that. Okay, but for now, just one method, one process. Done with magnitude, next angle. Okay, for angle, we need two curves. Again, same. We need the instantaneous value of Vs, instantaneous value of I here. Okay? Once you get them, you do something to get the angle. Okay? So let's at first get them together. Question is getting them together. Well, we got the instantaneous on one window, no problem. And this is in another window. Okay? But if I put them on the same graph, there is going to be a problem. Putting them on the same graph is the idea. But can I put them really on the same graph? Yeah, I can put them, no problem, but you cannot work on it. Because V, look at that. I mean, I'm talking about units. V is in volts, 5 volt maximum. I is in, no. I is in amperes, yeah, correct, but then again, let me just give you an idea. Look at the y-axis. The maximum value is somewhere here, and this guy says 20 milli. So less than 20 milli is the maximum value. Milli, you are working in milli. One guy is in volts, another guy is in milli. So if I put together, the volt is gonna be this much, and the milli is gonna be here, just like a straight line. You won't be able to see it. Too big, too small. You cannot see it. If you cannot see that, you cannot work on it. That's the problem. Okay? So, although I know for angle I need V, I need I, I need both on one graph, but I cannot work like that. I need to devise another way. Okay? So, solve the problem. How? Well, Also, you'll learn it in theory, but let me just give you the idea. This I is gonna go through this R. Okay? I has got value and angle, complex, R angle theta, that format. This V also got value, magnitude and angle. Okay? The angle of I and the angle of this guy are just the same. Why? In theory are just the same. So although you need this guy with that guy to do something, but you can replace this one using that one, because the angle is the important idea. Angle of that and angle of this are just the same. Okay? There is no difference. So you can use this in place of that, instead of that. And this is the way out. Why? Because this guy is also going to be in volts, not in millivolts. So volt, together, visible. You can work on that. Am I clear?
Yeah.
So summary, I summarize. To get the angle, we need this and that. This is too big, that is too small. On one graph, not possible to work with them. So I need to change this guy, not that guy. How do I change that? I change it with this. Why? Because the angle of this and the angle of that are just the same. Why? In theory, you'll get the answer. Okay? So right now, I'm going to work with this and that on the same graph in order to get this guy. Am I clear? Now, C window, let's get there. You already got VR, only VS is missing. I need to add VS here. How do I add that? Again, same process. Get to the first window. VVS plus is the name. You copy that, double click, copy, and then click cancel. You go to the third window and then go to add trace. And then paste. Click on OK. So done. VS appeared there, but thickness I need to increase. The color is red. There you can see that. Two curves side by side. Okay? Look at this. Red one is VS. Green one is VR. That means working like I. Working like I. Okay? That's it. So we now need to find this guy. Now the question is, how do you find it from those two parts? How? Okay. Let's say this is the voltage. Let's say this is VS. Let's say this is VR. Okay? And you now need to find something called phase difference. Okay? You now need to find out something called phase difference. That is going to be represented by this. Delta theta defines or indicates phase difference. There is a formula which is like this. 360 F delta T. F is frequency, which is in our case 1 kilohertz. Okay? Many instantaneous curves are here. Okay? All have got the same frequency. Source 1 kilo, I 1 kilo, this 1 kilo, everybody 1 kilo. Okay? The frequency is the same for all curves, all instantaneous values. Now, delta T is gonna be the delta theta is phase difference, delta is time difference. Okay? Time difference. So two curves are here. We now need to find out the phase difference, and for that we already got 360. If we already got, we need to have just delta T, the time difference. That means time difference is needed here. Okay? This is your time. And how do you find time difference? You take one point here, another point there, and then get the difference. Okay? So how do you select a particular point? For example, okay, you cannot go for just any point you like. Suppose if I choose this point, I need to choose that point as well. the characteristic of this point should be the same. Okay? For example, this is the maximum, also the maximum. If I select this, I need to select that. Why? Crossing 0, same characteristic. If I go with, for example, this, or for example, which one? This, I also need to go with that. Okay? So you now need to select 2 points based on their characteristic. The characteristic should be the same. So let's do it over here. For example, one cycle, another cycle. If I choose this, I need to choose that. If I go with this, I need to go with that. This, like that. Same characteristic, 2 points. Okay? Suppose I go with these two. Suppose these two, the first two. Then you can get the time difference in between two. Am I clear?
Yes, sir.
This is how we need to do that. Okay then, nice. Let's see what is going to be delta T. Okay, let me ask a simple question. Yeah, you. Shayan Khan, I suppose.
Yes, sir.
How can I just select those 2 points and get the delta T? How?
By using, sir, by cursor.
Yeah, cursor. Correct. Then what's the next point? Suppose, okay, you're gonna answer that. Okay? Andali, I suppose your name? Yeah. So he told me we need cursors to select this point and that point. Let's say I select this guy using a cursor. What's the next step? What's the next step? I need to get delta T. What's the next step? I mean, why am I selecting a point? Why? What to do with the point? What to do with the point? How to find delta T using a point? Using 2 points. How to find? Why am I selecting a point? What to do with it? What does a point have that can help me to find a delta T? What does a point have? Coordinates, fine. A point has a coordinate, but 2 coordinates, x and y. Which one should I use to find delta T? X coordinate. Why? Why x coordinate?
Because we are finding the time between two.
And time is on x. That's why we need the x coordinate.
Yes, sir.
Okay. So that gives the idea. Select 2 points, find out their coordinates, look for x quantity, the time. When you get the 2 times, you can get delta T, the difference between them. Am I clear? So I think you can do it on your own. I do not need to show that. Okay? Just briefly, click here, 2 cursors, anyone you like. For example, left one. Okay? Place it on green. You know how to place it on green. Okay? Select this point, then go for this button, mark label XY, that label here, then select that point. Okay? Again, by moving the cursor, select this point, again click here to get the label. Okay? That's it. That's the way how to get the information. Am I clear? So you can do it on your own at home. So when you get delta, 2 times, just find out the difference. Difference is always positive. So this is going to be bigger, this is going to be smaller. Subtract smaller from bigger. For example, this is 3, this is 5. 5 minus 3 is going to give you 2. So 2 is going to be this guy. Okay? And by the way, it's going to be in milliseconds. It's going to be in milliseconds. Okay? So, then you put that value over here, multiply with 360F to get delta theta. Delta theta is going to be in degrees. In degrees. It's an angle. It's going to be in degrees, not in radians. It's going to be in degrees.
Sir, what is F?
Frequency.
Frequency. What is the value of
This one. Okay. Now another thing to mention.
আপনি করেন নাই কেন? ইউটিউবে আপলোড হয়ে গিয়ে
Yes. দেখ তুই দেখ এইটাতে সিলেক্ট হয়েছে বাট এইটাতে কেন হচ্ছে না আমি তো সেই
শুনো এক ঠেঙ্গা ডান হাত দিয়ে তুলতে হয় এক ঠেঙ্গা বাম হাত দিয়ে
প্লিজ আচ্ছা দেখ দেখ বিষয়টা
এদিকে আয়, তুই এদিকে আয়, কাছে আয়,
হয় না তার শর্ট
এই বক্তা চোদা তোমার এখানে BR2 আবার RMS কেন এখানে RMS দিয়ে তুমি কি করছো
কোনটা
এই যে এই জায়গায় RMS কি করে ক্লিক করো ডিলিট মারো ওই যে সুন্দর করে ডিলিট মারো মারছো
মারছি।
আচ্ছা এরপর কার্সারে ক্লিক করো
এখানে
হ্যাঁ ক্লিক করছো এখন এদিকে দাগের দিকে কিছু করো না একটা সিলেক্ট আবার মাতব্বারি করে
কিছু তো করি নাই
আচ্ছা এখন ওই যে নিচে আসো লাল ইয়াটা দেখতেছো না ওই যে BS প্লাস আরে নিচে হ্যাঁ এই যে এটাকে ডাইনটা দিয়ে ক্লিক করো করছো এবার দেখো এবারে একটা করে বসাও একটা করে বসাও ওটা
হয়েছে না হয়েছে তো হ্যাঁ বাট দুইটা হ্যাঁ ঠিক আছে তবে এখন প্রথমত
Okay, one more time, please. You got the delta theta, the phase difference. Now you're supposed to get this guy. You're just one small step behind. Okay? The value of the angle is delta theta itself, but there is a question of plus minus. Okay? This is the only question which is remaining over there. You just find out whether it is plus or minus and you're done. If it's plus, then the answer is that plus delta theta. If it's minus, then minus delta theta. That is the answer. Okay? Suppose delta theta is 30 degrees, you found. Suppose. Then we need to select whether it's plus or minus. If it's plus, then the answer is going to be 30 degrees. If it's minus, the answer is going to be minus 30 degrees. Okay? Now, how to select whether that guy, that delta theta is plus or minus? How? Okay, this is how. Look at that. You need to find out the position of current with respect to voltage. Look at the language. Current with respect to voltage. Okay? Suppose this is the voltage waveform and this is the voltage point. Suppose that is the current waveform and this is the current point. Okay? You need to just find that out. Okay? Current with respect to voltage, which is here. Red one is the voltage of what? This. Red one is this one. So this V, this voltage is gonna be the source, the red one. And current, where is it? Do we have current over here? No, we have VR, which is working like current. So current means VR over there. We're interested in I, that means we're interested in green, this one. That means you're supposed to look for green with respect to red. Am I clear? So, the red is on the red point on the right, green point on the left. So voltage on the right, current on the left. This is the setting. It can be the opposite as well. For example, the green can be here as well. Here, like that, on the right, with respect to red. Okay? Two possibilities. If the current is onto the left with respect to voltage, then we say the current leads the voltage. We say. Okay? And if current is leading, okay, forget that. If it's on the right, if it's here, then we're gonna say current lags voltage. Okay? So lead and lag, two new terms. If it's lead, if you find the leading current, then the phase difference of this current is gonna be positive. And if you get the lag, if it's on the right, then the current angle, the phase difference, is gonna be negative. If current angle is positive, then impedance angle is going to be negative. If current angle is negative, impedance angle is going to be positive. Am I clear? So, we now need to just keep an eye here. Just use, this is the whole process. You don't need to go through it fully. For example, lead and lag. Just find it out from here. Is it leading or lagging? Green with respect to red, is it leading or lagging?
Leading, sir.
It's leading. So you know the answer. Leading means this guy negative.
Negative.
So if your answer was 30 degrees, this guy is going to be minus 30 degrees. Done. You don't need to go through this guy. Okay? This is the whole process. You just look here and there. That's it. Done. Yes, that's it. So, did you get the angle? I mean, how to get the angle? Did you just figure out? Is it okay? Is there any confusion? Okay then. So done with the whole thing, I suppose. Now I'm going to talk about the report. I mean, how to produce all those information, how to submit. I'm going to talk about that. You have to submit this one at first. Which one? This guy. This figure at first. How to do that? You already know, but I'm just showing you in short. For example, go to options, go to display option, check this option off, grid on. Why? Because there were many dots over here. I just removed those dots. Okay? So now it's plain and simple white. Then drag a box around the whole circuit. For example, this. Okay? Then click on edit, copy to clipboard. This option. Then go to Microsoft Word and paste. Let me just show you. Did you get that? That is how you get a figure, I mean circuit. But then again, one problem is there. You can see a border there. Okay? Now, how to remove the border? Select the figure at first, then go to, is it working? Go to picture, well, it's not responding. Okay, let me just wait a little bit.
Select copy to clipboard. Word open করতে হবে পেস্ট করতে Word open করতে হবে পেস্ট
Okay, right now it's gonna work. So you can see the border. You just need to remove the border. How do you do that? Select the picture, select picture tools. From there, go to crop, and you can see this border, this, and that. Okay, these are 4 things you need to work on. Okay, if you keep the mouse pointer on top of this border, the mouse pointer is going to change its shape. Then you click and hold and move inwards, not outwards. Okay, like this, that, this, and this. Okay, so the portion in shades, this portion, this are gonna go away. This is how you remove the border. But do not do something like this. Don't do something like this. This is gonna change the picture itself. Okay? So please keep an eye on that. Once you're done, click outside and that's it. Border gone. Okay then? Now, graph. You have to submit 3 graphs for this circuit. This graph, this, and that. How to submit that? This graph is done totally, so you can directly print it out from this software. How do you do that? Go to File, then just select Print and select other options. You know how to do that. So print preview this. Once you print it on an A4 paper, this is going to look like this. Okay? Graph number 2, I haven't completed. You complete it at home and then print. And do the same thing for graph number 3. Is it clear?
Yes, sir.
Is it clear? Excuse me.
Yes, sir.
So what to submit? You tell me.
This graph.
Only this graph?
No, the word file circuit copy.
Yeah.
The word file and this. The 3 graphs.
Only this graph?
No.
3 graphs?
3 graphs.
Okay, so that's it. 1 circuit, 3 graphs. This is gonna be the submission for experiment number 1.
IPL number.
Yes?
বুঝছো না? এটা আমি কি করবো? আইপিএল কি করবো?
Okay, hello. I was supposed to complete the full task over here, but I don't think we have time to do that. 3 experiments are here, which we need to do. Experiment 1 is done. The other 2 are remaining. Okay, so we're going to complete those 2. I mean both in our next class. Okay. After that class, please keep in mind. After that class, the second class. This is the first, and then there is the second. After these 2 classes, you're going to submit number 1, the software report, which is going to be in groups. I think we talked about it in our first class. So you know how to do that. Okay. So right after this class, go home, and you know you have got groups. So just tell 1 person or 2 persons to just complete the whole thing. Complete the whole thing right now, because you won't get too much time after we're done with the next class. Only 1 week time. So right after today's class, complete experiment number 1. Okay? Is it clear? And then another thing. After that second class, okay, the third class is going to be software exam. You have to appear for an exam in the third class. This is today's class, that is next class, and then 2 things. Number 1, software report. Number 2, exam. Am I clear?
না তো
বাবু
এটা আমি ফাইনাল আমার কমে
এই পুরো সেমিস্টার মজা না
Okay.
Mariam.
A little bit change in the schedule. Class number 3, which I was talking about, exam. There we're gonna take a hardware class, and then class number 4 is gonna be the exam. Just please check whether you have understood that or not. Class number 1 is today's class. Class number 2, software class 2. Class number 3, hardware class is gonna be, and class number 4, there you're gonna appear for the exam. But the report is here. Okay? Let me just write it. Soft report. So class number 3 is soft report plus hardware, and class number 4 is the exam. Thank you very much. You can leave.